Hello, number 8. What is the mean of time constant? So time constant is tau. Time constant is or equation. RC or definition, we can use the time taken is the time for the charge on the capacitor to decrease. Right? Charge on the capacitor to decrease to 37% of its initial value, meaning the initial value is a maximum Q0, and after the time constant, the charge on the plate capacitor or charge decrease to 37 from maximum charge or Q0. And number 2, suggest 2 ways to increase time constant, because the equation time constant tau is equal to time constant is R times C. So to increase the value of the time constant R, you can increase the capacitance or you can increase the resistance R. We go to the number B. Figure 6 show the 3 capacitor C1, C2 and C3 connected to a 12-volt battery. So calculate the total capacitance of the circuit. So we need to calculate the total capacitor. You consider the C2 and the C3, because this is a series circuit. So the circuit here, now this is a battery, and this is a C1, and this is battery 12 volt. So now if you combine the C2 and C3 here, this is combination C2 and the C3. And now the C2 and the C3, now this is a parallel. So to calculate the effective capacitance of the circuit, so first you calculate the C3 and C2. So effective capacitance C2 and C3 is 1 over C3 is 1 over 3, and plus C2 is 1 over 6. Sorry, this is microcoulomb. So C to 3, so now the C to 3 is equal to 2 microfarad, right? Use a calculator to calculate the C to 3. So now C to 3 and C1 is a parallel. So the total capacitance, total capacitance of the capacitor is a C1 and C2. C1 plus C2, 3. And the C1 is a 4 microfarad and C2, 3 is a 2 microfarad, and C total or C effective is 6 microfarad. And the next is calculate the charge store in the C3. So what is the Q or charge store in the Q3 or Q3, capacitor Q3? So now calculate the charge store in the Q3. So meaning you start from the equation, charge store in the Q3 is a C 3 times V3. But the V3 is voltage, yes, provided is here is a 12 volt. So the problem here is what is the value of the C3, right? So if you look at the diagram here, if you calculate the Q, this is a series circuit, meaning the Q on the capacitor 3 is equal to Q on the capacitor 2, right? So meaning that if you calculate the Q3, is same value on the Q2, meaning that if you write the equation here, so Q3 is C3 V3. So C3 is so here is a C to 3, and also V here is a V on the so the C23 is a 2 exponent minus 6, right? And V23 is equal to 12 volt. So the Q on the capacitor C3 is equal to 2.4 exponent minus 5 coulomb.